So, kids, we have one more friend for you in the class. Her name is Yasmita. This is her first class. So she's going to see what we do in this class, how much effective or boring this class gets. Maybe you might want to move a little bit to this side so that when I explain the concepts, I would see your reaction as well. Okay. So Yasmita, just for you to be aware, this tablet that you or iPad that you see here is primarily for recording what we are doing in the class. So what it means for you is you don't have to worry about taking notes of everything that we learn. You will only focus on following the concepts, asking me questions, arguing with me, debating, disagreeing, whatever. Okay. So your full focus and energy will go on for understanding the concepts, and while we understand the concepts, we do a lot of problems in the class also. So you will try doing that with me. If you get stuck somewhere, ask for help. There is no wrong question. Every question is right. So just feel as comfortable as you can, and don't have to worry about taking notes, because this video I will upload, which will be there for you to revise and catch up on what we learned. If you missed something, if you forgot something. Okay.
I still need a notebook.
Yeah, you do.
Yeah.
I will, because I will make sure that your hands get dirty by practicing some problems in the class. Okay. All right. So let me do a quick roll call. I see some kids are still not here, but we'll get started. So we have Arush, Dev, Neil, Riya, Ritika, Samriddhi, Shriyan, Viswa, and Vivan. Few kids are still missing, but we will get going. All right. So, what are we going to learn today? So, I have sent you an invite for joining the WhatsApp group, because that is where I publish the. You can do it later. So that is where I publish the timing of the class, link for the class, address for the class, which you anyways know now. And then once I upload the video of the class, I set the link also. It goes on to YouTube. I'm not a big time YouTuber. I have just only my kids as my subscribers and the parents. But this gives you access to that. And then whatever communication we do, that is through the WhatsApp group. So I had sent the topic for today's class. Let me do a quick rundown of what we are wanting to cover today. Okay. So primarily we'll be focusing on quadratic equation and exponential functions. Okay. We'll try solving some quadratic equations and functions, and then relate to some word problems. Now you will think that, okay, this is your first class, I'm jumping onto quadratic equations and functions in the first class itself. So don't worry about it. We keep going in loop. Okay. So there are total 13 units that you need to prepare for as part of SAT. So right now we are in the advanced maths unit, but we'll go to the next unit, which is trigonometry and geometry, and then again we'll keep going in loops. So I'll get you guys tired of all the concepts, and then so that when you come across any problem in the SAT exam, it will look familiar to you. Hey Davik, what happened? You're not coming in person? Davik?
No one else is coming in person. So.
Nobody is dropping you? No, so we have a new child in the class. Her name is Yasmita, and she was wondering, is she the only one getting tortured by me in person here? Okay, all right. So let's get started. So today we'll talk about quadratic equations and functions and related word problems. Hey Vishal.
Thank you.
So before I jump on to any problem for that matter, what do we mean by quadratic equations or exponential problems? Any idea? Any vague idea? Quadratic equations? Very familiar, you would have heard about it so many times. Yeah? So when we are talking about a problem relating to quadratic equation and exponents, you must be wondering what I'm going to talk about. Let's look at a real-time problem, okay, which I have noted down for you guys. I have an equation R equals 380 times 1.08 to the power t. Hey Tony, come over quickly, class has started. Okay, so we got one friend for you. She is Tony, she is Yasmita. Alright, so we are dealing with quadratic equations and exponents related problems, okay? It'll look fancy, difficult. Let's try simplifying them. So this is the equation that is given to us. And For all the kids who have heard me so many times, there is a concept that I follow and that I insist you guys to follow is ran. Do you remember? We talked about it. Who wins the race depends on who ran the best. Here R stands for reading. If you have a problem to solve, read it once, twice, 2 to 3 times so that you know what exactly is being asked. A stands for analysis. Who's wearing Nike shoes? Yeah, Tony. And this N stands for Nike. What does Nike say? Just do it. So in summary, this means you have a problem to solve, read it a couple of times, then put your thoughts together, analyze it, and then you recall Nike, which says now you do it. Meaning read, analyze, think through it, and then you start doing it. Where we go wrong is we pick up a problem, jump onto solving it. That is where if you took the wrong approach, you might end up wasting some time which you don't want to do in an exam. Yep, yeah, everyone.
So what happened to the T in front?
So I killed T. T was the, so here it was, there was a T before, which T stands for trust. Always trust that if there is a problem to solve, you are the one who can solve it. So I'm now assuming that you guys have grown up enough and everybody trusts that they can do it. Okay. So this is the lighter part of the concept that we believe in, but short and sweet summary of that is don't take a problem and jump onto it. Think about the problem. Come on in.
Paper.
Yes. I'll just take $20 from Daddy for the paper. I'm scared.
That's a broken.
I'm sorry, Dad?
Can I please borrow a pen, please?
Yes, sure. Let me see if we have one. Sit down, sit down, sit down. So the next one, I will keep some pens handy with me. I'm just keeping something that I don't have time to type. You can use this one.
Thank you.
Okay? You guys can use whatever you want to use. Okay, sorry. So that is the concept part of it. Read, analyze, and then do it. Don't jump onto solving it. Now, Yasmita, okay? You have some friends in the class. She's Ananya, and his seat Tony. So yeah. So now I'm going back to the problem. This is the equation given to us. R equals 380 times 1.08 to the power t. The given equation models the revenue in thousands of dollars. This one models the revenue in thousands of dollars. Thousands of dollars, okay? So probably this one is referring to revenue. We'll read through it. Models the revenue in thousands of dollars R. So this is the revenue of a company T years after 2012. So T is the number of years after 2012. So if I'm talking about 2013, this will be 1. If I'm talking about 2016, this will be 4. So you're counting from here. I'm just reading the question yet, okay? I'm not giving you guys any clue to solve it. Of the following, which equation models the revenue of the company Q quarters after 2012? So this is the model given, say, okay, revenue of the company in thousands of dollars after T years. It says, it has given us four options saying which of the below is modeling that in quarters. I'm just writing down the options, then we'll deliberate this and see where we are going with this. This is Q, okay? So I'm reading this question one more time. Like I said, Ran says read till you get tired. A says analyze, and then N says Nike, then you do it. So right now I'm reading the question one last time for you guys. This is the equation given. R equals 380 times 1.08 to the power T, where this given equation models the revenue in thousands of dollars or of a company T years after 2012. Of the following, which equation models the revenue of the company Q quarters after 2012? So this model is given in terms of years. You have to pick which of these options are relating to the revenue, same rate, same revenue, but calculated in quarter. T is the number of years and Q here refers to, let me put all small q's. Let me not get you guys confused just because of my stupid writing. Okay? So now, if Q is the number of quarters, this equation, if you have to represent in terms of quarters, which of this one is looking to be an option that you would want to go for? Are you guys clear about the question? I have read it so many times. If you want, I can read it one more time. So this is a model. Okay? Let's say if I say I have a model saying age is equal to weight times 5 divided by 4. I'm just making it up, okay? So if somebody is, let's say, 100 pounds, then multiply by 5 divided by 4. 500 or 480. Okay, so if somebody is 100 pounds, the weight is 80 years, let's say. I'm just making it up. So this is a model. It says, in this model you can fit in weight, let's say 200 pounds, and you'll see what the age would be. You plug in 20 here, and based on that you derive what the age would be. So likewise, this is a model in the form of an equation which says revenue is derived based on revenue is equal to 380 times 1.08, it's a factor, to the power T, where T is the number of years since 2012. Okay? So this is given in years. Now it says if you have to put the same model in terms of quarters instead of year, 1 year has how many quarters? 4. Yeah? Every 3 months is called a quarter. If you have to put that in terms of quarter, which of the equation below would represent that? Everybody heard the question on the screen? Davik, Vishal, Samriddhi, Arush, Ria, Ritika, everybody?
Yeah, I heard it.
Vishwa, okay. Tony, Ananya, and Yasmita?
Do you have another pen?
Oh, sorry.
Thank
You
you.
might want to use this marker. This is not a good substitute for this.
I have a pencil.
Oh, you can borrow. See, there's the advantage of having friends in class. Okay, so what's cooking up? How would you approach this? I'm not so very keen on getting the answer, but how are you going to how are you guys going to approach this problem? That's what I'm interested in. Think about it. Think like a child. You guys are a child any which way for me, but think like a real child. Anya is deeply in thoughts. Okay, in deep thoughts, sorry. That's the reason I don't teach English to kids. I'll mess up. Yeah. Tony, any thoughts? Come out of your comfort zone. Give it a try. Go wrong, it's okay. Vishal, what's cooking up? Okay, let me try simplifying this a little bit more. I mean, I'm just adding some more thoughts to it. Is that okay, guys? Sriyan, Arush, everybody okay? Now look at it. See, don't overburden yourself by thinking about this complex looking calculation. Okay. This is the revenue. This is the time, and T again. Break it down. If it's counting since 2012, maybe the company was formed in 2012. Maybe, okay? In 2013, what will happen? What will you do here? You have clocked 1 year since 2012. So you will put 1 in place of T. So this becomes 300 multiplied by, 380 multiplied by 1.08 to the power 1. You go to 2012, 2014, this t will be replaced with 2. You go to 2015, you will replace this with 3. Yeah? So we have muddled enough water so far. So far it was looking fine. We were talking years. Now it says we don't have to think in years, we have to think in quarters. Okay? Now let's take one simple example. Davik, Arush, you guys are very quiet. So far, is it haunting you guys or you're just thinking? Ritika?
I'm just thinking.
Thinking? Okay. Okay. So now let's look at it this way. I'm saying let's look at situation 1, 2013, after 1 year. Okay. What will this equation become for me? In 2013, I have clocked 1 year. Since 2012, I have clocked 1 year. So my revenue will be equal to 380 to the power 1.08 to the power 1. Okay. This 1 is year. Okay. Now, if I have to represent this in quarter, meaning whatever is the increase happening in 1 year, if I have to look at this in terms of quarters, I'm talking about this by 4. Yeah?
Yeah.
If I'm talking about 2 quarters, I'm talking about 380, 1.08 to the power 2 over 4. If I'm talking about 3 quarters, since 2012, I'm talking about 380, 1.08 to the power 3 by 4. If I'm talking about 4 quarters, then I'm talking about 1.08, 4 over 4. That is how it becomes 1 year. So whatever is my number of quarters, that is what I will put in the numerator and then divide by 4. Because otherwise this will not align with this guy. So basically you have to look at it. 1 year is equal to 4 quarters. So if you are talking in quarter, you are talking about 380. You have clocked 4 quarters by then in 1 year. If you are talking about 1 year, this is for 1 year, okay? Then you are talking about 4 quarters. 4 of quarters. Right? But you're not you're talking about whatever is the number of quarters, which is 4 quarters divided by 1. That is how you're getting a 1. So you're just to make it equivalent, you have to look at that whatever money I'm making in, whatever revenue the company is making in 1 year is equal to 4 quarters. So if I'm putting that in quarter, I have to divide that by 4 so that after 1 year if I compare, it will be 4 by 4 and these two will match. If I'm comparing after 2 years, it will be 8 quarters in 2 years, so it will be 2 here, and in terms of quarter it will be 8 divided by 4. That is how I'll get a 2. So that is how it will match. Am I actually making sense or I'm just convincing myself? No? Not making sense, right? Okay. So this is another problem with an elderly teacher. I don't get convinced unless I see a very confident yes on your faces. Who all, okay, don't be shy. Tell me who all was able to understand it and who all were having some doubt. Because I'm anyways going to do it one more time. I could see the kids here were not comfortable.
Can you explain it like one more time?
Yes, beta, for sure. Okay, so this is the equation given where t is years, okay, and it is starting since 2012. Let's take situation 2013, when by then I have completed 1 year, and that means I'll put t equal to 1, okay. So, and t equal to 1 year. How many quarters? So in years it will be 1, in quarters it will be 4 quarters, correct? Completing 1 year. So far, Ananya, okay beta? Okay. Now in 2013, this equation will change to what? 380 1.08 to the power 1, okay, in years. In quarters, it will be 380 into 1.08 to the power 1, but 4 quarters. So 4 over 4, that only will give me 1. So look at it this way, 1 becomes 1 is equal to 4 quarters. So how you get 1 is 4 by 4. Now look at this is 2013. If you go to 2014, you have clocked t equal to 2 years and number of quarters equal to 8. So what you are seeing here is this equation will become revenue will be equal to 1.08 to the power 2 in years, and 380 1.08 8 quarters by how much will give you a 2? 4. So basically every year, in year 1 it was 4 by 4 because it was 4 quarters. In year 2 it was 8 by 4 because it was 8 quarters in 2 years. So that is how you are getting it 2 here and 2 here. You are not changing the value of this equation. You are not changing the model. You are just redefining in quarters. Third year when you go to 3 will be equal to what? 12 divided by 4. That is how you are getting a 3. So that you are not changing the word revenue for the company. You are just repainting it differently. Yeah?
Okay.
Sounding convincing? Little better than before? Ritika, is it better now?
Yeah, it's better. I understood it.
Now after 5 years, 2017, this will become 5. If you have to represent 5 in quarters, in 5 years you know that okay, 5 years will be equal to 20 quarters. You'll have 20 times of 3 months repetition. But it has to be 5. You are dividing that by 5. That is how you are getting, dividing that by 4. Because this 4 represents how many years, how many quarters. Okay, so quarter divided by 4 will give you the number of years, and that is how it will match. So when this is 5, it has to be 20 by 4, then only you will get a 5 here. So you are not changing this thing. So if you are representing this, you are representing this as number of quarters divided by 4. Make sense?
Yes, sir.
Davik, Arush, Neil, Sarah, Saranya, everybody? Okay, so again, I have not taught any concept yet, right? I mean, I just showed you guys an equation and said, okay, this equation says, this model says this is representing revenue in terms of years. If you have to look at this whole revenue in terms of quarters, the number of quarters in any number of year would be 4 times of the number of years, right? So whatever is the number of quarters, if you divide that by 4, then only you are getting the number of years, which matches with this one. So, in other way to relate, I mean, since I was taking a very simple route to understand this, whatever I have in terms of years, my number of quarters will be 4 times of that. 4 times the quarter will be equal to number of years. Or the other way around is number of years will be number of quarters divided by 4. Correct? 1 year, 4 quarters by 4 gives you 1. 2 years, 8 quarters divided by 4 gives you 2. Likewise. Yeah? I hope I'm not getting you guys confused. Let's pick up another problem. Because these problems will get easier when we do more of it and get our hands dirty to relate to things. Tony, is it okay, understandable so far, or I'm getting you guys more worried? Better? Feeling comfortable? Okay. So again, just to repeat myself, okay? We'll keep emphasizing on this approach. Read till you get tired. Then you start thinking about it, then you do it. Let's look at the next problem. I have a drawing. These are all straight lines, okay? Don't go by my drawing skills. This is chickens. This is apartment buildings. apartment building. Somebody plans to enclose a rectangular area for his chicken in his backyard using the sides of his apartment building for two of the sides. Somebody plans to enclose a rectangular area for his chickens in his backyard. So maybe this was the backyard. This is the area that he has enclosed for his chickens. Building apartment building for two of the sides. So basically, pick two of the sides for the apartment building and enclose that for his chickens. If he has exactly 40 feet of chicken wire, 40 feet of chicken wire. If he has exactly 40 feet of chicken wire, what is the largest area in square feet he can enclose for his chickens? Okay. Now, this is one part of the problem. Second part of the problem says the width of a rectangular box is 2 centimeter. Width is 2 centimeter less than the length. Okay. The height of the box is 8 centimeter. Height, now it's getting more interesting. Height is 8 centimeter. If the box has a length of 8 centimeter, which of the following functions retain the surface area? Lot of information. Let's read through it. Somebody plans to enclose a rectangular area for his chickens in his backyard using the sides of the wall. Now the information here is sides of the wall, meaning this side and this side he doesn't have to put the chicken wire. Maybe because this is closed by the wall itself. If he has exactly 40 feet of chicken wire, 40 feet, this and this together is 40 feet. What is the largest area in square feet he can enclose for his chickens? Okay, I think I mixed up two questions. This is different. Okay, yeah. Let me. Okay, yeah. I'm stopping here. I was mixing up another question. Okay. So again, last time reading this question says. Somebody plans to enclose a rectangular area for his chicken in his backyard using the sides of his apartment building for two of the sides, as seen in the figure. If he has exactly 40 feet of chicken wire, what is the largest area in square feet he can enclose for his chickens? Did everybody hear the question so far? So, see, this is apartment building, this is the backyard. He's trying to use a rectangular area for his chickens. And obviously, you cannot keep your chickens open, let them roam around. So, he has to barricade. And he has exactly 40 feet of chicken wire. So, he has already bought the wires, which he will use for enclosing or covering this side so that chickens don't go to neighbor's house. Now, the question is, with 40 feet of chicken wire, what is the maximum area he can have for his chicken in square feet? Ritika, Arush, Neil, Sara, Vishwa, Vishal, what's cooking up? Saranya, yep.
So you're trying to say like the area
Mhm.
of this?
So basically, this is where the chickens will live, right?
It's the square.
It's a rectangular area, that's what it says. Davik, Vivan, what's going on? Dave, Riya, nobody saying anything. Everybody heard the question, right? Somebody is trying to use his backyard for keeping the chickens using two of the side walls. And he has exactly 40 feet of chicken wire. What is the maximum area he can have for his chicken? Yes, Vishwa.
I'm confused.
Confused? Okay. That makes me very happy. At least when we get confused when we are trying. So good that you are trying. Okay, anybody else? Neil, Ria, Davik, Dave. Yep. Yeah, Dave, go ahead.
Wait, is it so? It's just he has 40 feet of wire and he's using how big the pen could be in a square?
Yeah, what will be the area? So
Like a square or like a rectangle?
I'll read the question for you. I'll not tell you the answer, okay? Somebody plans to enclose a rectangular area for his chicken. Rectangular area for his chickens in the backyard using the side of his apartment building for two of the sides. So he'll use two of the sides as the apartment building only. As you can see, the apartment is like this, okay? And this is where this is where he's planning to keep his chickens. So he's saying for his chickens in his backyard using the sides of his apartment building for two of the sides. So two of the sides he's using the apartment building. So he doesn't have to put the wire. If he has exactly 40 feet of chicken wire, what is the area? What is the largest area in square feet he can enclose for his chickens? Yes, Davik.
Without a chicken wire, will it be open into the apartment building or is there walls?
Yeah.
Apartment building has a wall, okay? So they cannot walk inside the apartment.
So you want it
So I can
this?
do something.
I'm sorry?
I need to make sure so I can do this.
Okay. Yeah, Neil, you have also raised your hand.
The wall counts? Like the wall side?
So, see,
Oh wait, never mind.
I also know as much as is written in the question, okay? He plans to enclose a rectangular area for his chickens in his backyard using the sides of his apartment building for two of the sides. So he's using apartment building's wall for two of the sides. So basically, he's using only this side and this side for the chicken wire.
So just do 40 times 40.
Okay, keep breaking it down. Think. Yeah, Neil.
I think the answer is 399.
399. Wonderful. There's a shoe company named Bata in India. They keep the prices like this. You buy a shoe for $5.99, $6.99, $9.99. They don't say 1,000. Okay. Yeah, Ritika, go ahead.
Wait, so if it's asking for the area, then I got 400.
You got 400. Okay.
Like the chicken.
Okay. We'll see. Dave,
Yeah, I also got 400.
you also got 400. So Neil got 399. Neil was negotiating with the guy. Okay. Davik,
You said it has to be in a square, right?
I said rectangle.
Well then it's still 400.
400. You were saying something.
What's the side length again?
I'm sorry?
What's the length again?
One more time.
What's the length again?
I don't know. I have not been given that length yet. What do you think? 400? 400 what? Square feet. I mean, question says find out the area in square feet. Yeah, Ritika.
Wait, if it's in like a rectangle, then mine might not be correct because I think I might have done it as like a square because for mine when I got 400 and I put like both the like length and width as like the same amount, so I don't know if it works.
We'll see.
I have to check.
What is the alternate option? Think about it. Yeah, Neil.
Yeah. Can a square be a rectangle?
Square. Okay. Let me go back to the basics. What is a rectangle and what is a square? A square. Yes, you're saying something. You complete your chain of thought before I jump on.
I think it's 375.
375.
Yeah.
Okay. Now here the question is, what is the maximum area? Okay. We'll see how we can maximize the area. Okay. Now, first of all, The question says this in a rectangular enclosure. Okay, so it says it has to be a rectangle. Now, can a rectangle be a square? Yes, it is. Or can a square be a rectangle? I mean, a rectangle cannot be a square, but a square can be a rectangle. What is the property of rectangle? Say opposite sides are equal and parallel. So this and this will be equal and parallel. This will be equal and parallel to this one. Yeah. What does square say? All the sides are same. So this and this are same, and opposite sides are parallel to each other. Yeah. Now, is every rectangle a square? No, because rectangle can have sides different. Meaning these two pair of sides and these two pair of sides could be different length. But in case of square, every pair will be the same. So is every rectangle a square? No. Is every square a rectangle? Yes. Rectangle only says by opposite sides have to be same. A square has that. So every square is a rectangle, but vice versa is not correct conceptually. Yeah. Now it says it has to be a rectangle. Now let's break our head a little bit more here. So the first thing is, it says it has only 40 feet of chicken wire. Okay. So this length and this length has to be together. Let's say this is length and this is width. So length plus width has to be 40. This is my first equation. Okay. Now, what is the maximum it can have? Let's look at what if it is, let's start from length is 0 and 40. Is it possible? No, right? What will you do? Where you are covering? If I'm saying length and width, okay? 0 and 40 if I take. I'm talking about this length being 0. I'm just hanging a wire. It is not good enough to enclose it, right? So 1 is out of equation. 1 and 39. This is the minimum I can think of to begin with. I mean, I can also think of 0.5 and 39.5. I'm not going there. 1 and 39 if I take, then my area is length times width. 39 into 1. Yeah, length into width. Okay, it says maximum size, right? If I go 2 and 38, 76 square feet, increasing. Let's jump a little bit further. 10 and 30, 300 square feet. Yeah, length is 10 and 30, length times width. This is my area. I go to 19 into 21. 19 1 is 19, 19 to 38 plus 1, 39. This is what Neil got probably. 19 1 to 19, 1 carry forward, 19 to 38 plus 139. Yeah. Then I go to 20. It became 400 square feet. Now let's decrease the length. Make it 21 and 19. Again, this is the point where I am getting maximum area. If I make it 2119, it becomes 399 square feet. If I make 22 into 18, it becomes 18 times 2 is 36. 3 carry forward, 18 times 36 plus 3, 396. So see here, when you are keeping one length and one width, adding up to 40. You have to always make sure that you are adding up to 40. 139 gives you this much. 2020 gives you 400. Then when you increase the length further and decrease the width, this thing is decreasing. Let's say I keep increasing the length to 39 and width to this. It starts from 39, keeps going up and comes down to this. There's some interesting finding from this thing. When the length and width both are matching, that is when I'm getting maximum area for keeping my chickens. Now the finding from that is, if you have length and width combined, and you have to look at the maximum area from this, you get the maximum area when you are dealing with a square actually. That's why, that's the only situation when you got this maximum. See, your length and width both are matching. This is 20, this is 20. And this is a rectangular area, right? So this is 20, so this will be 20. This is 20, so this will be 20 also. Essentially, you converted, instead of a rectangle, you made it a square. Yeah? Neil, did you think little bit extra to get to 399? Probably you thought that it says it has to be a rectangular area. As soon as it became 2020, it is a square. So that's why I'll pick up something which is less than a square. Was that your thought process, Neil?
Yeah, but I didn't know that squares can also be rectangles.
I'm sorry, Vito?
I didn't know that squares can also be rectangles.
Yeah. So I'll still go with this, okay?
Yeah.
Because this is the maximum area. Ultimately, here the objective is the maximum area has to be. I mean, from this length, we have to get to the maximum area so that we can keep maximum chicken in that enclosure. Yep, that's the idea. Is everybody with me?
Yes.
Was that too stupid a problem to deal with? Chicken in math problem? Okay, alright. Everybody with me? Ananya, okay? Yeah. What happened, Ananya? Okay, Vito?
Yeah.
Yeah, okay. And let me know if you guys feel it very hot here, okay? I can turn on the AC. I just found the temperature being right, so I've not turned on the AC, but if I do so, it creates a little bit of noise, so that's why I'm avoiding that. And no mosquitoes bothering you guys, right?
No.
If mosquitoes are bothering you, this is what you need. I mean, I have 2 machines working for you to kill them, but in case, if you see any, let me know. Alright, so far everybody okay? Dev, Saranya, Sriyan, Vishal, Vishwa, Vivan, Ria, Arush, Davik, everybody? Tony, okay? Yeah? Okay. Now going to a problem which will look more like a math problem. So hear me out carefully, okay? The width of a rectangular box is 2 centimeter. Width of a rectangular box is 2 centimeter less than its length. Width of a rectangular box is 2 centimeter less than its length. So if I'm talking about a rectangular box, then it says the width is 2 centimeters less than its length. So if let's say this is my length, if this is my length, this is length minus 2. Is that okay?
Yeah.
The height of the box is 8 centimeter. So now we are talking about a 3-dimensional box maybe. This is length minus 2, which is width, and there is a height also. So let's say this is this. So this is not length minus 2. This is, let's say, length minus 2. This is my width and this is my height. It says if the box has a length, where did I go? Width of rectangular box is 2 centimeter less than its length. The height of the box is 8 centimeter. So this is given as 8 centimeter. If the box has a length of x centimeters, which of the following function represents the surface area in square centimeters? Wonderful.
Can you say that again?
Yeah. The width of a rectangular box is 2 centimeter less than the length. Okay. And height is 8 centimeter. If the box has a length of x, meaning it's saying, okay, don't say L, say x. Length is x. So this will be x minus 2. Okay. Which of the following function represents the surface area S in square centimeter? Surface area. Who all remembers how do you find out the surface area for cuboid? No, it's okay. Let's see. Yes, Ryan.
Isn't it length times width times height?
Length times width times height, that is surface area. No, that is volume.
Oh wait, oh yeah, no, that was wrong.
How do you calculate the volume? I'm just giving you as a clue, okay? If you have a three-dimensional object, the volume is nothing but you take the area of the base, multiply that by height. That is the volume always.
Yeah.
So here if it is length, it is width times height. That is your volume. If you are talking about volume of a right cylinder, you find out the area of the base. Here it is pi r square times h. So this is the volume, okay?
What are the sides of the, like, I can't really see it. Does it show it?
Okay, I will read it for you, okay? So, I have not given the options here, okay? Because if I give the options, that will not let you guys get stressed out a little bit. I'm a little bad teacher who's wanting to bother you guys to some extent.
It's a cube first.
It's a cuboid. So, you guys know the difference between a cube and cuboid, right? If you are making a three-dimensional object from a square, where length, width and height all are same, that is a cube, like an ice cube. 1 centimeter, 1 centimeter, 1 centimeter. That is a cube. When you are talking about cuboid, you are taking a rectangle and expanding or raising it vertically. So that's a cuboid. That's the difference. Okay. So yeah, Vishal, go ahead. You were saying that you don't. So the question says the length and width of the rectangle is like the width of the rectangle is 2 centimeters less than the length. So if my length is x, this is x minus 2. And the second line of the question says, let's say the length is x. Okay, so that's how I'm relating to x as my length and x minus 2 as my width. And the height is given as 8 centimeters. Now we have been asked to find out the formula for surface area of this cuboid. Yeah. Now let me give you guys one more clue. If you're talking about surface area, meaning you're talking about everything that is visible on the surface.
The sun.
This is a classic example of a cuboid, not a perfect cuboid. It has round corners, but assume it's a rectangle. Talking about this area, this area, this area, and this area, this area, and this area. So you're talking about 6 sides altogether.
So this line times width times 6.
Think a little bit more.
Plus,
I'm sorry, Peter?
you add them all together.
I will come back to it. But keep thinking. Don't stop your chain of thoughts. Look at it. This is one side. This is one side. This one is height. This one is length. This is width. If you're looking at this rectangle, does anybody recall what I'm trying to go towards? Davik, Arush, Ritika, Dev, Vishal, anybody? Saranya, Riya, anybody? See how desperate I am as a teacher to wait, who is waiting for the answer to come from one of you.
Wait, the answer includes the bases too, right?
No.
No.
Okay, let me do it the way I would want you guys to think about it. We are talking about surface area of a cuboid. There is no object better than, no, there is one. This is a cuboid. Every side that you see is a rectangle. Yep. Everybody with me so far? So, let's say this is my length and this is my width. Okay? So, this is length, this is width, and this one is height. Okay? And you are already given that width is 2 centimeters less than this. So, my length is x and width is x minus 2. And height is given as h. Now, if you're trying to find out the surface area of this cuboid, you're trying to find out this area and this area. These two are opposite and same. 2 times this area. This area and this area are same. So 2 times this area. And this area and this area are same. So 2 times of this area. So I have 3 pairs of matching surfaces. this, this. Yep. So two pairs of, let me play with colors a little bit. Two pairs of the red side. One you are seeing in the front, one in the back. Two pairs of green side. One in this side and one the opposite side. Then we are seeing two pairs of the blue side. One at the top, one at the bottom. Now, when you look at the red side, 2 times of that will be 2 times of the red side's area. How much is that? X into H, X, this into this. This is a rectangle, right? Perfect rectangle for us. Length into width. Area of this one. 2 times of X into height. Height is given as 8. One is done. One pair is done. One surface area is what? It's a rectangle, length times width. This is my length X and width is 8 given to me. Now, am I getting you guys confused? So, see, we are trying to find out the surface area, right? Every surface, every side that you see is a rectangle. What is the area of a rectangle? Length into width. Yeah? So, I am taking this rectangle, the red one. If I count this as a length and this is my width now, which is 8 centimeter given to us, height. Yeah? Not convincing?
Didn't you say it was height?
Yeah, I can say height. I can say height. Not a problem. So, okay. Let's say this is height, okay? Let's not worry about it. This is height, this one is height, this one is height, this is also height, and this side that you see is also height. Yeah? So my red one will be X into height, length into width, okay? I am calling it height, but when I look at this as a rectangle, for me these are two sides, one side and this side, okay? So X into H plus 2 times of green one. Now green one, if I look at green one as a rectangle, one side is what? X minus 2. This is one side. And what is the other side? That is H. Yeah?
Yeah.
Then let me go to the blue one. Blue one has length as this X and this width is X minus 2. Yeah? Yes or no? So, Milana, you have joined 5 minutes early, beta, okay? I'll just, no, not Milana, this is I think Noah. So Noah, just wait for 5 more minutes, okay?
Okay.
Yeah. So, again, I'm breaking it down. This is a cuboid where the length is X, width is given as X minus 2, which was given to us in the question, and this was the height. Height is given as 8 centimeter, let me call it height for now. So if I have to find out the surface area of this guy, I have to find out 2 times the red one in the front, one in the back, which we are not able to see right now, plus 2 times the green one, so this side and this side, and 2 times the blue one. So that's why I multiplied by 2 outside, and then I have X into X, the red one. This is the area of this guy, 2 times of that, it covers for both front and back. Then I'm talking about the green one, which is, this is one side and this is the other side, X minus 2 into H. Okay? And then I'm going to the blue one. Blue one is this side multiplied by this side. Yeah? So X into X minus 2. Now here, H is given as 8 centimeter. I'll replace every H with an 8. Yeah, you are here, but you're not here for next 5 minutes. Alright? No, not for you, for him. Okay, so here, now if you break it down, it becomes 2 times X into 8 is 8X, plus X into 8 is 8X, 2 into 8 minus 16, plus X into X becomes X square, X into minus 2 is minus 2X. let's simplify this. We'll add all the terms from the same family. So I have only one x squared. So 2 times of x squared. Then with x I have 8x here, 16x minus 2x. So that is 16 minus 2, 14x. And then I have minus 16.
But where did you get x squared from?
When I multiply these two. Yeah? Is it making sense or no?
I get it.
Everybody with me? Samriddhi, Ritika, Davik, Neil, Sarah. Sarah is not here. I called Sarah's name a couple of times, but Sarah did not join today?
Yeah.
Okay. So, what is the summary of what we have learned so far? Kids from level 1, guys, wait for 2 more minutes. I'm still wrapping up the class for the elder ones. So, in this class, we have not picked up any new concept. What we are dealing with is, how do you deal with equations or word problems? Quadratic equations and word problems. Based on the equation given to us or based on the model given to us. First problem that we dealt with was where we had a model given for a year and how did we convert that to a quarterly model. Okay. So we just split 1 year into quarter and then we use that as a denominator for finding out how do we do a comparison. And what we did was we just did some sampling. Okay, 1 year what happens, 2 years what happens, 3 years what happens, and then based on that we could see that okay, my formula to remain the same, my revenue to remain the same, I have to just divide that by 4 when I'm moving from year to quarter. Yeah. Likewise, when we looked at this problem had a rectangle relationship given to us, and then we say okay, it has a height also. That means it became a cuboid, and this was a relationship given. From that we have to find out the surface area, and for finding out surface area, there is a formula that you can remember. Surface area of a cuboid is 2 times length into width plus width into height plus length into height. But you don't really have to remember that. Just draw a rough sketch. From that you can make out, like the way I colored it. Yeah. So that way, as long as you remember how to find out the area of a rectangle, you can relate to it. Yeah. It just needs a little bit of visualization is what I would insist on. But otherwise, it's not a big problem, and that's why you will think that okay, 1 hour wasted, nothing taught. But what we are doing is we are doing the practice together, so that when you see a problem, how do you deal with it without even bothering to know the formula or to figure out how to approach it. Yeah, it's all about the RAN theory, because you guys have learned a lot of things by now. It is when it comes to word problems, it is more to do with how do you relate the word problem, convert that into something in the mathematical form, and then you solve for it. Yep. All right. With that being said, we have come to the end of the class. I'll let you guys go. Once I upload the video, you can probably watch it one more time and see if you're able to connect the dots. And then I'll suggest you guys to go to Khan Academy, and for this particular topic, try doing the unit test. Not to test yourself, but to test your teacher to see whether whatever I was blabbering in the class, is that useful for you to be able to do it yourself or not. Yeah? Alright. Have fun, kids. We'll talk to you guys again tomorrow, same time.